After determining the velocity of a rolling body on the inclined plane, we are going to derive the velocity acceleration of a rolling body on the inclined plane. For that, again we will make use of kinematical equation. The second kinematical equation that we used to have, v square is equal to u square plus 2 into a into s, where v is the final velocity of the body, u is the initial velocity of the body, and a is the acceleration with which the body is moving. We know that the body which is released from height h on the inclined plane has initial velocity 0, and hence you will have v square is equal to, I will write this equation as v square is equal to 2a into s. Just before this only, we derived an expression for v square, that is 2gh divided by 1 plus k square divided by r square is equal to 2a into s. Therefore, what acceleration is equal to? This acceleration is equal to 2 into gh divided by 1 plus k square divided by r square into 1 divided by 2s. Now this 2 get cancelled, and we will get this acceleration is equal to gh in the bracket 1 plus k square divided by r square into 1 divided by, what s equal to? H divided by sine theta. Therefore, it is h divided by sine theta. This h get cancelled, and hence you will get acceleration for a rolling body on an inclined plane. A is equal to, denominator will go in the numerator, and hence you will get, that is g sine theta divided by 1 plus k square divided by r square. This is the required equation for the acceleration of a particle in acceleration of an object rolling on the inclined plane. Now hereafter we will derive what is the time required by a particle, object, rolling object, to roll on an inclined plane so as to displace it through a distance of s. For that, again we will make use of second kinematical equation, that is s is equal to ut plus half at square. Here the initial velocity u is equal to 0, and as we know what s is equal to, s is equal to h upon sine theta. Therefore, I will write it as h upon sine theta is equal to 0 plus half. Here what acceleration just now we got, it is g sine theta divided by 1 plus k square divided by r square into t square. Now here we will get like this one, what t square is equal to, it will be 2h in the bracket 1 plus k square divided by r square divided by g sine square theta, 2h. What h is equal to? H is equal to s sine theta. Therefore, t square is equal to 2 into s sine theta divided by 1 plus k square divided by r square g sine square theta. Here theta, one of the sign get cancelled. Therefore, t square is equal to 2s in the bracket 1 plus k square by r square g sine theta. This is the required equation for the time period or the time required to roll an object on the surface. This is the required equation. This equation is in the form of height through which it is raised, and this equation is in the form in which the body has displaced through a distance of s. Like this, we are able to determine the velocity, acceleration and time for the rolling object on the inclined plane. With this, hereafter, we will see how the different object roll on the surface and what will be its velocity at the bottom, acceleration at the bottom, and what the time required to reach at the bottom, and who will take the maximum time to reach at the bottom, who will take minimum time to reach at the bottom, and though it is released from the same height, why they need the different time interval to reach the bottom on the inclined plane. That to be studied in the next part of our lecture. Here on the board I have taken a tabular form of this rigid body. Here I have written the rigid body. The first one is ring or hollow cylinder of mass m and radius capital R. Its moment of inertia is mr square. The other is disc or solid cylinder. Its moment of inertia is mr square by 2. This moment of inertia is about its own axis. For these two, the axis is perpendicular to the plane of revolution and passes through the center. If this is top is a circular disc, then axis passes through center and perpendicular to the plane. This is the solid sphere. This is moment of inertia about its diameter. This is a hollow sphere. Its moment of inertia about the diameter. The moment of inertia is written in the form of radius of gyration as I is equal to mk square. Using these three formulas, I is equal to mk square, v is equal to under root of 2gh upon 1 plus k square by r square, a is equal to g sin theta divided by 1 plus k square by r square, t is equal to under root of 2h 1 plus k square by r square, g sin square theta. We will find out the values of the velocity, acceleration and the time for these rolling bodies on the inclined plane from a height h. Now we will start with the finding the values of k square by r square, then v, a and t. We will start with the first one. For the ring, I is equal to mk square, and if mk square is equal to mr square, as we have taken from here, therefore k square is equal to r square, the value of k should be equal to r, and value of k square by r square should be equal to 1. This is the one thing that we get. For other, I is equal to mk square. Mk square is equal to mr square by 2. Mm get cancelled. K square is equal to r square by 2. Therefore, the value of k is r by root 2, and k square by r square. K square by r square should be equal to 1 by 2. This is one more thing that we get here. For third one, the solid sphere, I is equal to mk square is equal to 2 by 5 mr square. Mm get cancelled. K square is equal to 2 by 5 r square. Therefore, it should be equal to under root of 2 by 5 into r is the value of k. Then value of k square by r square should be equal to 2 by 5. This is one more thing that we get. And in a very similar manner, we will get the radius of gyration for this hollow sphere, it is equal to 2 by 3 r, and k square by r square should be equal to 2 by 3. Like this we will get the values of the radius of gyration and the value of k square by r square, which is required in the latter equations. Now hereafter we will see what will be the value of velocity here. For ring, velocity is it should be equal to v is equal to under root of 2gh divided by 1 plus k square by r square. What is the value of k square by r square for the ring? It is equal to 1. 1 plus 1, 2. 2 divided by 2. The velocity should be equal to under root of 2 to get cancelled. Therefore, what remains here is under root of gh. Like this, we will get the velocity of the ring or the hollow cylinder. Then we will go for the next. For a disc, what v is equal to under root of 2gh divided by 1 plus k square by r square. The value of k square by k square by r square is 1 by 2. 1 plus 1 by 2 is equal to 3 by 2. 3 by 2, denominator will go in the numerator, and it will be equal to 4 by 3 gh. This is the value for the disc. That is root of 4 by 3 gh. In a similar manner, we will get here v is equal to under root of 2gh divided by 1 plus k square by r square. K square by r square is 2 by 5. 2 by 5. That is 5 in LCM. 5 plus 2, 7. 7 by 5. And 5 will go in the numerator. It will be 10. 10 gh by 5. It's under root of 10 by 5. 10 by 7 gh. 10 by 7 gh. It is 5 plus 2, 7 divided by 2. 2 goes in the numerator. It is 10 by 7 gh. And similar to that, k square by r square is 2 by 3. 3 plus 2, 5. 5 by 3. Then it will be 6 by 5. It should be under root of 6 by 5 gh. These are the velocities. What important is not here mathematics, what we are doing here. We will see out of all the 4, rather out of all the 6, which one has greater velocity? Which one has greater velocity on the inclined plane? Here it is gh, it is 4 by 3 gh, it is 10 by 7, 6 by 5, it is 1 gh, it is 1.33 gh. When you divide it 4 by 3, it will be 1.33, it will be 7, 10 by 7, it is 1 point, what remaining here, it is 1.28 like that, and it is 1.2. Therefore, disk has the maximum value of velocity. Disk is therefore moves with greater velocity on the inclined plane. Thereafter, in a similar manner, we are able to determine the value of acceleration here. The value of acceleration here is it will be g sine theta divided by, I should write it as 1 plus k square by r square. K square by r square here is 1. 1 plus 1 is 2. It is g sine theta by 2. Then again for the disk, it is g sine theta divided by 1 plus k square by r square is 1 by 2. 1 plus 1 by 2 is 3 by 2. It is 2 g sine theta divided by 3. Then it is a is equal to g sine theta divided by 1 plus 2 by 5. 2 by 5. 1 plus 2 by 5. 5 plus 2, 7. 7. Therefore, it is 5 by 7. 5 g sine theta by 7. Then last one is g sine theta 1 plus 2 by 3. 3 plus 2, 5 divided by 5. 3. It is 3g sine theta divided by 5. These are the acceleration of different bodies on the inclined plane. What important here is to say that the different bodies will have different velocity, different acceleration, because they have different shape, and as they have different moment of inertia and different radius of gyration. Though they are allowed to move on the same inclined plane from the same height, and that does not depend on what mass they possess, that does not depend on what mass they are having, but that depends on what shape they are having, and from what height they are released, and from at what angle the inclined plane is inclined with the horizontal law. That are the factors on which the values of velocity and acceleration of a moving body depends on the inclined plane. At the end, we will determine the time taken by these bodies to reach at the bottom, to come to the bottom by traveling a distance of s from a height h, that we will determine. And the job again, what we will do here is we will find out the time. How to find out the time? It is under root of, I should write it as 2h divided by g sine square theta in the bracket 1 plus k square by r square. 1 plus k square by r square is 1. That is 1 plus 1, 2. Therefore, it will become 2 into 2, it will become 4h divided by g sine square theta, under root of that. That will be the time required. Then we will go for the next. It is 2h. 1 plus k square by r square. 1 plus 1 by 2. 1 plus 1 by 2 is 3 by 2. 3 into 2 is 6. 6 by 2 means it is 3h. 3h divided by g sine square theta. This is the time required for the disc or solid cylinder to roll on the inclined plane of height h. Then it is 2h 1 plus k square by r square. K square by r square is 2 by 5. 1 plus 2 by 5. It is 7 by 5. It is 14 by 5 h divided by g sine square theta under root of this one. This is the time required. Then the last one is 2h. This will be under root of 2h 1 plus k square by r square. K square by r square is 2 by 3. 1 plus 2 by 3. 3 plus 2, 5. 5 into 2, 10. It is 10 by 3 hg sine square theta. H upon g sine square theta is common everywhere, but it is 4. It is 4. It is 3. It is 2 point something, and it is 3 point something. Therefore, this time required for the ring is maximum time. From this, what you will get? The velocity in this case, it is more than 1, it is more than 1, it is more than 1. It is only 1 only. Therefore, it's the integral multiple of 1, and it is more than 1, 1.33 under root of gh. It is more than that. It is 1.2 under root of gh. Then it is more than that. Therefore, the velocity of the ring is maximum. Velocity of the ring